For more than 4,500 years, the Great Pyramid of Giza has stood as one of the most studied structures on Earth. Millions have walked its narrow passages, and historians long believed its secrets were already uncovered. But now, scientists are scanning the pyramid with cosmic rays that pass through solid stone, and what they've revealed may change everything. Deep inside the pyramid, researchers have mapped a massive hidden chamber that no human has ever entered, and according to the latest data, it may not be empty. The Great Pyramid, built for the pharaoh Khufu around 2550 BC, consists of approximately 2.3 million blocks of limestone and granite, weighing an estimated 6 million tons. For centuries, the only way to find out what lay inside these ancient monoliths was through destructive force. In the 9th century, the Caliph al-Ma'mun literally hacked his way into the pyramid's core, creating the robber's tunnel that tourists still use today. In the 19th century, explorers used gunpowder and dynamite to blast their way through the stone. By the late 20th century, when antiquities authorities established strict, non-destructive protocols, the physical exploration of the Great Pyramid reached a dead end. Science needed a completely new kind of shovel, one that could dig through solid rock without leaving a scratch. The solution came from the violent deaths of stars millions of light years away. Every single minute of every single day, the Earth is bombarded by cosmic rays. When high-energy particles from supernovas and black holes crash into our planet's upper atmosphere, they shatter the air molecules, creating a cascading shower of secondary subatomic particles. Among these newly born particles are muons. Muons are the heavy, fast-moving cousins of electrons. What makes them incredibly useful to scientists is their unique interaction with physical matter. A muon can easily pass through the empty air of a hidden room, but when it hits a dense, solid object like a block of granite, it loses energy and is either absorbed or deflected. By placing electronic sensors at the base of a massive structure, physicists can catch these muons as they rain down from the sky. It is exactly the same principle as a medical X-ray, but on a colossal scale, utilizing the background radiation of the universe. Fast forward to October of 2015, when an international coalition launched the ScanPyramids project. Their goal was to use modern, highly sensitive muon detectors to look inside the Great Pyramid of Khufu. After 2 years of patiently collecting data, the team published a bombshell paper in November 2017 announcing the discovery of the Big Void. It was an entirely unknown one, massive cavity located directly above the Grand Gallery, at least 30 meters long. It was the first major internal structure found in the Great Pyramid since the Middle Ages. The announcement sent shockwaves through the archaeological community, but it was also met with fierce skepticism. Traditional Egyptologists initially urged caution, noting that ancient Egyptian engineers often left large gaps filled with loose sand and rubble to relieve the crushing weight of the stone above main chambers. Because the 2017 muon scans were relatively low resolution, depicting the void as a blurry cloud, it was impossible to tell if it was a neatly carved room or just a jagged gap in the masonry. However, the ScanPyramids team continued their work. By 2023, they gathered enough data to confirm the existence of a 9-meter-long corridor near the original entrance. They drilled a millimeter-wide hole through the mortar and inserted an endoscopic camera, capturing the first visual footage of a hidden space inside the Great Pyramid in over a century. The video showed a rough-hewn, vaulted stone corridor that was entirely empty. While some were disappointed by the lack of gold, the discovery proved that the particle physics was perfectly accurate. With the technology validated, the global scientific community realized they needed a much bigger lens to look at the massive Big Void deeper inside. This realization gave birth to the Exploring the Great Pyramid (EGP) mission, a collaboration involving Fermilab and the University of Chicago. They designed a system of muon telescopes upwards of 100 times more sensitive than the equipment used in 2017. These new telescopes, housed in temperature-controlled shipping containers and utilizing scintillator strips from high-energy physics accelerators, are designed to measure minute variations in density within the void itself. This is where the intersection of quantum physics and classical archaeology requires an advanced digital translator, a role heavily supported by the Giza project at Harvard University. Directed by Peter Dermanwelian, the project maintains the most comprehensive digital archive of the Giza Plateau in the world, turning old excavation records into highly accurate three-dimensional models. When the physicists capture their muon data, it looks like a massive spreadsheet of trajectories, To make sense of it, researchers build a perfect digital twin of the Great Pyramid using Harvard's architectural models. They then program a computer to simulate billions of virtual cosmic rays raining down on this digital pyramid. By comparing the simulated muon tracks to the real-world muon data recorded by the telescopes, the scientists can mathematically carve out the exact shape of the unknown spaces. It is through these incredibly complex, high-definition simulations and the deployment of the next-generation detectors that the narrative has radically changed. As the EGP mission refined its focus on the Big Void in 2024 and 2025, the blurry cloud of the 2017 data began to sharpen into focus. The new, high-resolution tomographic images did not show a random, jagged cavern of loose rubble, which is what one would expect from a simple construction gap. Instead, the data began to suggest clear, intentional geometry. More importantly, the scans revealed localized density anomalies at the base of the void. In the precise language of particle physics, a density anomaly means that the muons are hitting something that is not just empty air, but is also not the standard, uniform limestone of the pyramid's core blocks. There are distinct, irregular shapes residing inside this massive chamber. This is the origin of the explosive realization that the void is not empty. The anomalies detected suggest the presence of materials that could range from carved granite and alabaster to dense organic matter like heavy cedar wood or even concentrations of metals. The implications of this data are profound. If the 30-meter space above the Grand Gallery contains physical objects, the theory that it is merely a relieving chamber collapses completely. Relieving chambers were never used to store artifacts. If there are items inside this void, it means it is a functional room, intentionally sealed off from the rest of the pyramid by its builders. This has reignited the oldest and most captivating theory in Egyptology, that the king's chamber, discovered empty and ransacked centuries ago, was nothing more than a magnificent decoy. Pharaoh Khufu knew that the tombs of his predecessors had been heavily targeted by grave robbers. It is entirely plausible that the true, unlooted burial chamber of Khufu, containing his mummy, golden funerary mask, and accumulated wealth, was built high up in the core of the pyramid and sealed behind impenetrable walls. The Big Void, heavily guarded by millions of tons of rock and only visible to cosmic radiation, might be the actual resting place of the Great King. This brings the scientific timeline crashing into the present day. For years, the Egyptian government kept a tight lid on the interpretations of the ScanPyramids data. However, the tone has dramatically shifted. Dr. Zahi Hawass, the former Egyptian Minister of Antiquities, has begun to publicly tease a monumental revelation. During a panel discussion in late 2025, Hawass announced that a massive new archaeological discovery inside the Pyramid of Khufu will be unveiled to the world in 2026. He stated unequivocally that this discovery will rewrite the history of the pharaohs. According to Hawass, the advanced equipment has detected a specific 30-meter-long passageway that ends at a sealed door. He is speaking with the confident authority of an archaeologist who knows exactly what is waiting behind that door. His promises suggest that the international team has found a way to look past the sealed stone, perhaps using microendoscopy or highly advanced thermal imaging to complement the muon data. The timing of the Great Pyramid announcement in 2026 seems perfectly orchestrated to center the world's attention firmly on Egypt, cementing the legacy of modern Egyptian scientists uncovering their own history. As we approach the official announcement, the scientific community remains in a state of hyper-focused suspense. The journey to this moment represents one of the most beautiful intersections of diverse scientific disciplines in human history. It took the brilliant architectural minds of the ancient Egyptians to build a structure so perfect that it survived for 4 millennia. The meticulous excavations of historians to map the visible corridors, and modern quantum physicists using subatomic particles to see through the walls. The Great Pyramid of Giza is no longer just a static monument of the ancient world. It has been transformed into a dynamic laboratory, a massive stone hard drive that is finally giving up its encrypted data. Whether the 2026 announcement reveals the intact mummy of Khufu, a massive hoard of undiscovered artifacts, or architectural secrets that completely change our understanding of ancient engineering, one fact is already undeniably clear. The era of using dynamite to discover the past is over. We have finally learned how to listen to the stones, and after 4,000 years of silence, the Great Pyramid is finally speaking back.